So for game development, there are many challenges, but today we'll talk about these three. So one, the first thing, across many of the tools that we use and love, there really is no great ground truth that allows these tools to work more freely with each other, and especially when you start getting into tools that are outside of the general entertainment business, like CAD tools. So bringing CAD data into the game development environment is also pretty difficult. So there really is no good ground truth. And that includes not just the model, but also the animation and materials that can spawn multiple games and pipelines. Additionally, teams are often distributed. People working from home, contractors, global teams, and there's not a lot of great solutions to connect everyone together as they work on these assets.
すごいね、これ。
And lastly, the
次世代
scale
の
of these
ゲーム開
projects
発スタ
are
イ
at
ル
a
ですよ。
point where it's almost a breaking point, right? The
まあで
budgets
も
are at
超未来かもしれないけど。
are just ridiculous to get a lot of these games done, and so there's a lot of risk behind each game, and there's not a lot of sustainable asset development and reuse between multiple generations of games and generations of engines. So we had a lot of similar issues ourselves. That you know NVIDIA as a graphics company, but we do so much more beyond just our GPUs, right? We do AI and autonomous vehicles and robotics and medical, and it's a bunch of really interesting projects that we work on. And this was a problem for ourselves. We need to build these virtual worlds and work with teams, just like a game development team would, to build these worlds that our AIs can simulate in, and factories can run, and autonomous vehicles can drive in. And so we have a lot of artists and teams that work the same way. And we ran into these challenges ourselves. So the first thing was, one, just connecting our teams. We needed something to enable this kind of real-time collaboration across teams across the world. We needed the tools to be much more open with each other, where there was a ground truth asset that can live between tools. Because often we make decisions like, well, if I'm going to do this thing, I'm going to use this engine or this tool or this game development tool. And it's not always the same for the project you want to use. So you want the data to be able to flow more freely between them. So we needed a ground truth there. And lastly, we needed the tooling to be extremely extensible, because the scale at which these new worlds need to be built is immense. Like, for example, these autonomous vehicles, we need to drive them from New York to California. And it's going to totally change the way we need to work and to scale across a global workforce. So to solve a lot of these challenges, we came up with a project called Omniverse. And Omniverse was two things for us. One, it was a collaboration platform to enable all of our teams to work with each other collaboratively, and even across tools. And secondly, it was a simulation platform where we can take all of our NVIDIA technology and connect it into this virtual world and simulate on top of it. More for things like, again, like robotics and for autonomous vehicles and things that were just needed to scale across multiple nodes, multiple GPUs, immense scaling capabilities. And we wanted to all have a central hub of truth here for these assets and worlds. So we put this in a collaboration environment called Nucleus. I'll tell you more about this. Now, again, we initially built this for ourselves, and then we realized that this is really powerful for a lot of industries, for games and for movies and for AEC and design and manufacturing. They all needed the similar things. They all wanted to be able to build these big worlds and collaborate with each other across multiple tools and to simulate them in the most physically accurate manner as possible. But allow you to use the right tool for the job, right? And some tools you might want to use a game engine for, obviously to do a game, but you may want to develop those assets in a physically accurate rendering to make sure that you have the right asset that's going to last through multiple games and multiple generations. And I'll get more into that, but that's kind of the core concept, and we believe this is going to help a lot of people for multiple reasons. And today I'll walk you through that for games. So the core of this,
これはピクサーのやつですね。これはもう2012年ぐらいから。
So USD is what we found to be the great ground truth across many of these tools. Now, USD is developed by Pixar. It's an open source scene description that allows you to, translate your models and scenes and lighting information across multiple tools. And But it does something much more interesting than that. It allows this concept of layering and opinions. This means you can have teams that are large teams add layers of information on top of that data. And I'll give you an example. Like a USD scene can be a cup. Another USD scene can be an opinion, so it's like a layer that cup is blue, and another USD layer can be an opinion that cup is laid out 1,000 times. And you can structure this data this way in these layers to allow collaboration across large teams and different personas.
まあ、USD っていうのはものすごい大規模なその 3D 空間を記述する言語なんですよね。
At the core of Omniverse is this
まあだから
platform.
オープンワールドから洞窟に入って、洞窟に入ったらその洞窟の中がこうなってて、でもしも洞窟の中になんかネズミの巣があったら、ネズミの巣はこうなっててみたいな階層構造になってるんですよね。まあ表現できるという。
First was just we need all the tools to speak USD. Max, Maya, Revit, SketchUp, Rhino, Unreal, Houdini. We want and many more. We wanted to all speak USD, be able to collaborate with each other more easily, live collaborate, transfer materials across these different tools, and this made it really freeing for artists just to use the right tool for the job as when they're building stuff. And on top of that, we created a little SDK that allows you to easily make your own connectors
このニュークリア
into this Omniverse.
なんだ
And then Nucleus
Nucleus
is a collaboration hub. It's a service that you can put on your own
原子核
machine,
みたい
put
な
on-prem, you can put in the cloud.
ね
It allows
ニュー
multiple
クリ
tools
ア
to talk to
の
each
同
other
じ語源ですよね
in a live
原子
workflow,
核みたいな意味です
or
よ
you
ね
can do live collaboration between users across locations. But you can also just use it for standard version control of your asset development. But if there's a USD file that's in Nucleus, it understands it even more. It knows how to do deltas and diffs of USD, so you can do really fast replication of changes. And then we built a toolkit on top of that allows you to make your own, on top of the USD, it allows you to build your own tools. Like it uses Python, you can develop your own widgets or UIs for like level editing or asset review and approval, whatever you want. But it allows you to build these workflows on top of it. And this toolkit can be used to create microservices or apps to solve these little problems. And then simulation, everything we build in NVIDIA, physics, AI, behavior, animation, we all made them plugins into Kit. So you can leverage everything NVIDIA builds as part of that solution. And lastly, we built a renderer from the ground up and built on RTX. And the reason why we did that is because there's really kind of two types of renderers. There's that are out there today. That there's the rasterizer, super great for console game development and mobile, and it's really, really fast, real time. But it doesn't scale necessarily well across multiple GPUs and multiple nodes very well. So geometry complexity can become an issue when you start getting really, really large environments or using film-like quality assets in real time. On the other end of the spectrum, you've got path tracers and final frame renderers that are really great at scaling across multiple nodes, multiple CPUs. You can throw tons of geometry at it, but it's not real time. But it can be physically accurate. So we built something right in the middle, which was we felt we needed something that was multi-GPU, multi-node, physically accurate, and ray tracing from the ground up. So we built this RTX renderer that allows you to use film quality assets and do it in real time, as well as do high quality path tracing on top of it to get physically accurate results. So it really becomes kind of a ground truth viewer that you can use for your asset development before you decide which engine it's going to go into or what final frame renderer you're going to use. It kind of serves as a ground truth that we can use. That's really fast. And if you need to make it go faster, you throw more GPUs at it. So the idea is more about scaling up than it is about scaling down. And this renderer uses MDL, a physically accurate material model that we also open sourced and include with this that allows you to get that translation across multiple tools, but also gives you a material that can scale from real time to offline. Now, this renderer also is built on top of Hydra. So Hydra is another API that's developed by Pixar, and it's another open source API for rendering that you can have multiple renderers on top of USD. So now there's renderers like Storm from and RenderMan or HydroDelegates on top of USD, and we've added the RTX renderer as another HydroDelegate. So on top of Omniverse, we've built apps. As I was telling before, is Omniverse is a platform, and you can use Kit to build apps. So we developed a bunch of apps that come with Omniverse, and some of them are pretty cool that you can do. One of them is audio to face, allows you to take audio files and use AI to make facial animation out of it. We have Omniverse Create, which is basically a tool to do layout, lighting, rendering on top of the USD data. So it's really like a ground truth USD editor. And then there's Kalen, which allows you to do AI research on 3D objects. It's really cool. And then Machinima for doing storytelling on top of USD. And then there's View, which is a viewer, super high quality but easy to use to do path tracing and on top of, again, content that can come from CAD, manufacturing, game assets, or film assets. And then lastly, there's Isaac Sim, which is a robotics simulator on top of USD. But there's lots of great apps in development that you can get, and you can develop your own, which is great about the platform. So it is a workstation, means that I can set up Omniverse on my own computer. And when I do that, it allows you to connect all the tools that I'm already use and love. Right? If I'm using Max or Maya, Blender, whatever it may be, it's going to connect all these tools to each other and allow you to collaborate with those tools more easily and in real time. And also give you a photorealistic rendering of that asset as you're building it, so that you can get an idea of what the ground truth should be, what the lighting should look like, what kind of reflection should it have before it goes into any kind of game engine or again any kind of final frame. And then of course you can do this all live. You can connect this live between your game engine and your asset development and this kind of ground truth view, all live with each other. And I'll give you some examples of that.
Cross-tool collaboration.
So in this video, we show Maya on the left, connected into Omniverse, and I'm doing some modeling. And on the right-hand side, I've got Omniverse Create on the second monitor that's connected into that same nucleus. It allows me to see live edits happening with Maya, so I can see a real-time view, path traced, in the larger context of the scene as I'm building the asset. So it's serving as like this great viewer of that data. And then I can just open up Unreal and continue to do more edits. I can use Unreal to do level editing or layout. So the whole idea around Omniverse is that use the best tool for the job. If you like layout tools in Unreal, use that.
Omniverse Viewer で見れるんだ、そのレートレのレンダリング結果をリアルタイムで。
It connects them all together so they can work more seamlessly with each other. Where it gets more interesting is that you can start doing this across global teams. So now you can take a nucleus, which you had in your workstation before, and now put it on-prem or in the cloud, and you can have multiple users and teams all connected into that same database and start working with each other. So again, it allows you to connect these tools with each other. It can scale across large teams, and again, I can give you this kind of physically accurate review of what you're building. So in this example, we've got Unreal on the top left, which is doing some layout of a scene. And I have another user in Substance that's just painting up the textures that are going to be used in that Unreal scene. And then I have another user in Maya building new assets that are being placed in that scene. And I can see all of them live together as a producer or art director in the create view. So I'm actually reviewing the scene as it's being built.
左側3つが3人別々のアンリアルエンジンだったマヤだったりなんだりを全然でしかも作業内容が違っててそれを同時に進行しててその作業過程を右側で見られると別の人が
You can use AI and tagging to search for assets that you don't need another barrel for this game. You can search for a barrel. You probably made 50,000 of them in the past, right? So now you can find that barrel. And if you're using USD and thinking of things of kind of more of a ground truth asset, you'll build that asset so that it can last longer. You'll build it with higher fidelity and higher resolution textures. But then from there, you can
ナチュラルランゲージサーチ、自然言語でライブラリ検索できるんだ。赤い帽子とか黄色のソファーとかでその素材が出てくるみたいな。
So this will obviously reduce costs. The less you have to go remake and go find assets you already have, the better. And then the life cycle of that asset can last again through different games cycles. And then another really cool thing is you can run microservices on those assets. So once the asset is in this Nucleus database, you can start running microservices on it, like AI or baking or LOD generation or whatever you want. That's part of that kit framework. So here's an example of what Nucleus looks like. I can just go on my browser. This is even localhost. This is my own machine on a workstation. I can type localhost, and it'll give me that a view of what a Nucleus on my machine. And from there, it looks like a standard kind of like a Google Drive or Dropbox type thing, and I can create new folders and projects within here. But where it starts getting more powerful is that you not only have this ability to have these projects, but you have permissions and you have groups, and it's really built for teams. So you can create new users easily. So here I can just add a new user, add myself, Frank, and then I'll add my email address, whatever I need here, and create a new user account. And once I create this user account, I can go back to that project and then associate that project with that user and give that person special privileges, either sharing or read-write access or whatever I want. So here I'm going to add myself to that project folder, and I can give permissions for that folder. So you can easily set up your own projects, invite people to those projects, and set up permissions. That's the first thing you want to do. And once you do have your project, then you can just start putting content in there. And it can hold any kind of content. You can use FBX files, texture files, Maya files, doesn't matter. You can put whatever you want inside of Nucleus as a collaboration hub. And then you can easily start sharing that data with each other. So here I can just grab a bunch of textures, and I can kind of mass import a bunch of textures and things in here. And now I have my FBX files and my textures all kind of up in that project. Now, the other neat thing about the way Nucleus works is everything is a URL. So every path to every one of these assets is just a URL, like a web page. Like you can just give me a URL and I can get to that asset. But I can also add things like tags. So I just selected that FBX file and I gave it a tag for Max, that it came from Max. And I can go search on the top for that tag, and it'll find me that file. So you can tag assets and give them special tags to search for things. I can just search for regular file names too.
ここがハブになってるってこと
But you can search
か
for。both tags. You can see when it's highlighted like a little square like that. It's a tag.
ね、ウェブブラ
Or
ウ
you
ザ
can
ー
just
か
search
ら
by
使えるんだ。
by the name of the file. It'll find me anything that's named that way. But here I did a search for
オムニバースっていう名前から想像するものとちょっと違ったな。
So it's pretty cool. Within this database, you can start marking things like, which game it was in, or the level of detail of that asset, or any kind of tag you need. And you can add to these things pretty easily. But again, here I can see,
まあでも地に足がついた感じのいいシステムな気がするけど。本来はこういうのマイクロソフトかなんかがやるべきことなんだろうけど、今はもうこういうことをリーダーシップ持ってやるのって NVIDIA になってきたのか。要するにいろんなツールだったりいろんなミドルウェアだったりをなんかこう融合というかコードに連携させて使うフレームワークを作ったってことなんですね。だからこれにオムニバースに賛同したツールメーカーがオムニバースに適したインターフェースでツールというかツールの他のツールへエクスポートするインポートするしかもそれがリアルタイムでねリアルタイムのエクスポートリアルタイムのインポート手段の窓口を規定したってことですね。へえ。
Once I do have data in Nucleus, you can run microservices on it. So here's an example. You can see all the tools on the left, and Maya and Houdini and Blender and Unreal, and they're all connected to Nucleus, and they're uploading and editing their data on it, and so you can all kind of live collaborate with each other.
でも
But
NVIDIA
if my
は
data is
何
in
で儲
Nucleus,
け
then
る
I
ん
can
だ、こ
start
れ。
running microservices on it.
まあ確か
You
に
see things
レ
like
ンダラーの部分
physics
は
or file
RTX を使うって言って
conversion
るけ
or
ど、
AI or whatever you
ゲー
want.
ム開発って
So one
NVIDIA
of
の
the services
GPU
we
だけ
have
で動くものを作ってる
pretty
わけじゃない
cool
から
is
な。
deep tag.
でもあれか、ビアは
And what
NVIDIA
we'll do
の
is
RTX でいいって
we'll
こ
go
と
through
か。
all your assets,
最終的
we'll
に
generate thumbnails
商
for
品発
them,
売するの
make sure it
は、
has the right angles,
まあ
right
AMD
lighting,
ベースの
generate
ラ
really
デオ
good
ンでもいい
thumbnail
し、
for it.
ゲーム機でもいいっ
And
て
then
ことなのか
it'll
な。
have meta
とりあえ
tags
ずツールの、
of information within the
ツールとか
in
ミ
that
ドルウ
asset
ェアと
that's
かを全
we'll
部
figure out
有機的
what it
に
is.
つなげて、しかもリアルタイム
Car, is
で
it a wheel, is it a... It'll do that
マル
for
チ
you
ユーザーの
automatically.
コラボレーションができて、
And it's
しかもそ
pretty
の
it's
結果をリア
pretty
ルタイムで見
pretty
ることが
powerful.
できると。
Let me show you that in action. So here I can now search my Nucleus database for assets. So
自然言語
what
や
I
ん
can
のか
do
な。
here is I can just type in anything I want.
う
If I
わ、
can
す
see the whole
ご
the
いアイテ
database
ム
that
がい
I'm
っぱいあ
using
る。
today, our team is working on is got
うん
over 120,000 assets. I can just type trees instantly. Boom, found me all the trees
うん
that I want to use. But the great thing is I can use natural language. I can just type large red tree and it'll find me a large red tree. Now, the user didn't tag these assets. No one did anything to tag these
うん
assets.
タグ入れないんだ。
AI is automatically
へ
metadata
え、
on
すごい。
these
タグがあれだ。
assets.
ライブラリ
Find
の
them
中
really
の
quickly. But again, with
デー
natural
タ
language,
を
I
勝
can even
手に
misspell
AI がタグ
brown
付けして
rusty
くれるんだ。
barrel.
それはすごい
And
ね。
it'll find me a brown
あ
rusty barrel.
ーあ、じゃあ、
And associated with each of those images is
そ
the
の
URL,
ニ
so I
ュー
can drag and drop it into any
ニ
asset.
コラス、ニコ
But
レア
even
ス、
beyond typing,
こ
I
の
can just
サー
drag
バー
an
部分に
image.
GPU
I
サー
said,
バー
give
があ
me
るってこと
cars
か。なる
like
ほど。
this in my database, and it found me a couple red cars that are similar to that type of car. So you can just use images. As you can imagine, I'm working on a scene and I want bricks. I have to look something like this. Do we have anything?
ああ、
And
これ
boom,
に
we'll
近い
go,
もの。
we'll
ああ、
search
なるほどね。近いものをピックアップして
materials,
くれるんだ。
textures,
ああ、
and
い
so
い
yep,
ね。
found something as close
す
as
ごいね。これやっ
possible.
ぱそのサーバー側にそっか、
It's
NVIDIA の
pretty
GPU が
amazing.
入ってる
And of course
こ
you
とが
can
重
keep
要って
going.
こと
You
です
can
ね。自然言語だけじゃなく
you know,
て、
different
こ
types
れ
of
に類似な素
materials
材が
here,
欲しいっていう検索ができるんだ。
gravel.
あ、すごいな。
And it'll find me not only materials of gravel, it'll find me any models of
なるほど
rocks
ね。
that are close enough to that gravel.
細かい砂利の素材が出
So
てくる
I can't even tell you how helpful this has been for us. And it's a great tool for asset development.
と。
And even
GPU。
things, obscure GPU, it finds our models of our GPUs that we have in our system, and or
まあ
where it gets crazy is I can type, it'll find words
ああ、なるほど。
in the image. So
お母さんに電話ってやると。ああ、なるほどね。90ってやると、それに近い文字が、ああ、なるほど。あ、すごいね。
So it's pretty neat. I think AI is going to really change.
素材の検索がこんな風にできるのか。
Now we've taken this natural language search and we add it directly into the apps. And this allows you to just access things much more easily. The same way I was typing before, looking for Nicholas, I can just type dome light and boom, it finds me dome light. And I can type clear, it'll give me a clear sky. And it'll just automatically add the clear sky. And I can type change it to cloudy day and it will just put a cloudy day in. So I can search assets really quickly without having any UI at all. In fact, I can go find that tree again. Now I can just drag it into the scene, and it will allow me to drag assets directly with this search directly into that scene. So it allows you to search through your database quickly, find assets, drag and drop them, find materials, textures,
その
lighting, whatever you
AI っ
want.
ていうとなんか AI だけがフィーチャリングされるけども、このマイクロサービスレベルで AI が入ってくるのって気持ちがいいね。もう人工知能が使われてるっていう意識なしに機能を使ってるってことなんですね。へえ。なるほど。これをシステムを動かすにはサーバー側に NVIDIA の GPU がいるってことですね。タグ付けまで AI が勝手にやるっていうんだから。
Let's talk about ground truth a bit more. So, ground truth to me means that you have a raw asset that can travel through time as you're working through many projects. It's that asset that
面白いね。
be as high fidelity. It's not really thinking about a very specific target at that time, meaning it can be work across multiple games, multiple studios, multiple projects, multiple teams, and it's raw in the sense that that it's not the Maya file or the Max file. It's the combination of all those different tools together into one form that can move back into any one of those tools, but it won't be inconsistent. It won't change version to version of tools, and it won't change between vendors. It'll be the core asset. That's something you can say, well, it should look like this. What's wrong, right? So it has to be physically accurate. Material should be right, and unless you're not trying to go for physically accurate style, you can also do that too. But you can have a physically accurate lighting and representation of that asset. Give you a much longer asset life cycle, of course. And then the great thing too is also that this data is open source. It doesn't matter what tool you love today, you might not love that tool tomorrow. So you want that data to be in a form that can move freely between these projects. So, and this is all built on open source, right? So the scene description is open source, materials that are applied is open source. And we also added PhysX to if you want any kind of physical representation, physics assets on these things. That's also open source.
この辺のフレームワークはもう全部オープンソースにしちゃうけど、このニコラスっていう、中核となるハブの部分はあれですね、NVIDIA の GPU 搭載のサーバーじゃないと動かないんですね、きっとね。なるほどね。
on top of that, you have another layer for lighting, you have another layer for the materials assignments, and all these things can be broken up into pieces so you can decide which level of this raw asset you want to use. And again, you can have this ground truth of what it should be after you develop it, and then you can use that natural language search and go find that asset, and then you can have microservices.
今でもね、一つの例えばキャラクターな一つのシーンを作り出すのにいろんなツールを使うんだけど、その使ってるツールの、ね、データをこっちのツールに出すためにコンバートとかああいうのをやらなくてもこのオムニバースの仕組みを使うと、ツールが勝手にこのオムニバースのインターフェースに対応しているのでサクサクそのインポートエクスポートみたいのをリアルタイムでオートマチックに全部やってくれるということですね。すでにそのインポートエクスポートが行われているってことすら意識でしないで済むわけですね。
In this example, what I'll show you is that building this asset inside of 3ds Max, but I want to verify it inside of Unreal while it's being built. So you can see that while it's being built, I'm going to verify it in UE4 and I can get the scale right and get the right shape, make sure it's good. So as I'm building
左が 3ds Max で右が Unreal Engine だったんですね。
And start adding the texture and materials and see it in this kind of physically accurate lit
way. 3ds Max でキャラクター作って、それで Unreal Engine に配置してっていうのが、なんかデータのエクスポート、インポートみたいなの使わなくてももう、まるで同じツールの別ウィンドウみたいな感覚で操作できちゃうんだ。すごい壮大なプロジェクトだな、これ。こういうツールって実はね、各ゲーム会社が独自で開発してたりしてるんですよね。自分たちの自社エンジンにマヤをリンクする、3ds Max をリンクするみたいなことやってるんですけど、それをオープンソースでありとあらゆるツールをこのオムニバース、NVIDIA オムニバースに持ってこようと。すごいな、これ誰考えたんだろう。ジェンスンなのかな。確かに使い手も嬉しいけど NVIDIA もこのシステムを使わせるためには NVIDIA の GPU を買わなきゃいけないから NVIDIA としては儲かるわけですね。ハードウェアの GeForce が GeForce じゃないか、もしかしたらテスラかもしれないけど GPU サーバー
Additionally, I can live link this to the game engine. So while I'm developing the level,
I can start Unreal Engine にリンクして、その結果をレイトレじゃなくて普通のゲームエンジンのラスタライズエンジンに出力してレンダリング結果を見られると。
this kind of live connection feature to do that. And here in this example, in Omniverse Create, there's a really great feature
す
called
ごいね、これ。
zero gravity. It's a way to use physics without setting up complex physics on level layout. So I can quickly lay out assets using physics properties on it. So as I move the object around, it will automatically collide with the right things. I can turn on gravity when I want. And it just makes placement so much easier because normally, you're trying to line it up exactly right, and be touching the floor. And that's kind of a pain. So with zero gravity, you can just really just turn on.
重力をオンにすると配置できると。
And I can adjust things in real time and again see it fall over physics and just behave properly. And with the live linking, I could see what it looks like in Unreal too at the same time while I'm developing it. So here I have just like a bunch of rocks. So you can really kind of do anything you want. You can use any kind of physics assets, rocks or
あと10分で終わりか。
flat planes, shapes like pallets. And it doesn't really matter what the
マイ
shape.
クロソフトじゃなくてやっぱこういうのやんのやっぱ NVIDIA ってことになるか。もうちょっと前じゃ考えられなかったけどな。NVIDIA がこんなプロジェクトの舵取りをするなんて。まあ確かにマイクロソフトじゃないもんな。こういうのやるのって。やっぱ NVIDIA か。AMD ができなかったことは残念ですね。AMD ってやっぱな、こういうエコシステムを作るのがちょっと AMD はダメだよな。AMD はやっぱハードウェアメーカーなのかな。NVIDIA もそうなんだけど、NVIDIA はこういうエコシステム作るのにすごく力入れてるからすごいな。
Another great feature of Omniverse is its ability to stream this real-time ray tracing and path tracing to any device. So in this example, we use it as a way to have a window into the world. And allows anyone, an art director or a producer or anyone who wants to review the assets can just connect their iPad or tablet up to an Oculus server and open up the URL and you can jump right into that world. And the cool thing here is that it's actually not transferring the data to the iPad. It's just sending a pixel stream to the iPad. Plus, it's sending the USD camera information replication back to Nucleus. So it means anyone can see the camera moving around in their worlds. So here you can see the UE4 user has the scene open, and they can see exactly where the iPad user is walking around. So they get an idea where that user is and what they're looking at, and they can make changes to the world live. Because there's really no deploy step.
なるほどね。プレビューしてるときにリアルタイムに シーンの更新ができるんだ。
And here is another UE4 session jumps in VR. So they're using VR, and we have some AI-driven legs to fill in the rest of the body. But that person's now walking around that world in VR, and the tablet user can see them, and the VR person's in the world, and the person editing the world can still see them all together, and you can just keep adding people into this virtual world to make changes live. So again, Omniverse is this platform.
オムニバースのソフトウェアスタック。やっぱ RTX GPU がね。
Omniverse is a platform for collaboration and simulation. But if you look at the whole stack, this goes all the way down to the GPU, where we make changes to the drivers to make sure that the rendering is fast, and all of our graphics technology and SDKs are all integrated into that kit, so you can access destruction and flow and flame. Anything that we build. DLSS, Cloud XR, all that is available inside the Omniverse platform. And then we make extensions on top.
キットエクステンション。まあそこがいわゆるダイレクト X 的なですね。抽象仮想ってことか。
And again, you should look at it from the sense of, well, what problem do I have in my studio? Do I want to just make asset development pipeline easier? Yes, this is great. It's a great way to collaborate and have reviewers. Do I want ground truth rendering of my light baking process? That's another option. So it's really up to you. Look at the pieces here and see if it solves a problem for you and it can fit into your existing
industry users.
So again, we've made these apps on top. Another one I'll just give you a quick highlight on is just audio to face. Audio to face is really powerful. Allows you to do,
これすごいよね。音声さえ与えれば、顔面のこの口のアニメーションを作ってくれる、口パクアニメーションを作ってくれるってやつですよね。
can map it to any other face. So it's really meant for conversational AI, lots of narrative where you want to change the language. You want to change language of the speech without trying to do facial animation. It's not a replacement for things like facial motion capture or using an iPad to capture your face and emotion. It's really to capture conversational AI and then layer on top of that directed animation.
まあリアルタイムできるからライブでも使えるってことか。バーチャル YouTuber 的なことでも使えそうだな。
But this is what an app looks like. It's very different than what Create looked like. It's very focused on just the specific purpose of driving facial animation through AI. Now, the face that's being used here is a completely 3D scanned capture of a real person, all their facial expressions, and then the AI creates a network to figure out how to move the face based on speech.
So here's the live mode. 1, 2, 3. I'm speaking live. There's no recording. The UI is changed. I can switch back to normal mode by hitting here, and I'm back to my normal mode when I can play. This is another sample. You can select any other track.
Bonjour, je m'appelle Jarvis.
And that's it. That's the demo of the audio to face recorder and live mode. Thank you.
競合メーカーどこなんでしょう。いや、ないんじゃない今のところ。この発想のやつはないんじゃない今のところ。各ゲーム開発会社とか映画制作スタジオ、映像制作スタジオが独自で実装してますけどね、こういうやつ。これと似たようなやつを。それのスタンダードを作ったというところなんでしょうね。
It figures out this is the area they want to map this kind of thing. So it means you capture a lot more detail. You capture the muscles and the neck and around the face and all that. So if I play this clip, you can see now I can take that same character. As I play a clip back on it, it's going to transfer that animation to the face of the other character. We also see some additional tools.
まだですね、ベロまではやってないんですね。
Export this back out to Maya as a cache. And use it in your pipeline however you see fit. You can generate blend shapes from this, or you can map it to an existing character. It's going to be a great tool.
いや、まだこの全部のツールを抽象化して相互連携して一つのものを作り上げて、しかもマルチユーザーで同時に制作するっていうスタイルのものって僕聞いたことないんで、多分これが初めてなんじゃない？他のメーカーがその後追従してくるかどうか。まあ NVIDIA との目的は明確で、このオムニバースを動かすためには GPU サーバーが必要だから、まあそこで GPU 売れるってことですね。これを無料にしたところで動かすための GPU が必要なんで、その場合に GForce というよりはやっぱね、あれですかね、GPU サーバー、テスラとかですかね。ちょっとよくわかんないですけどね。なるほど。なんかもうちょっとデジタルツイン的な概念かと思ったら、どちらかではもうちょっと地に足のついたコラボレーションツール系のツールコラボレーションか。ツール同士のシナジー効果を作り出してみたいな。で、まあ、それにはいろんなシミュレーターとか、シーンビアとかいろいろあるんで、まあ、結果的に究極的にいけばデジタルツインのね、みたいなものができるようになるかもしれないけど、スタート地点としてはかなり現実的な概念ではありましたね。この後は、まあしばらくないんですよね。まあ他にもいろいろセッションあるんで、興味ある方はね、GTC2021 自分で登録すると無料でいろんなセッション見られるんで、僕はもう今日はこれで終わりかな。この後ね、まあちょっと AMD 絡みのオンラインミーティングがありますけど、まあ、気が向いたら17時、18時のレイトレ系のセッション聞こうかなと思ってますけど、これなんか面白そうなんですよね。これもやっぱオムニバースのやつなんですけど、これオムニバースで映画を作るみたいな話ですね。まあ、さっき今やったのはゲームを作るって話でしたけど、まあほぼ似たような話になると思うんですけどね。なるほどね。終わりますか、じゃあ。ではでは。 まあ勉強にはなったけど、まあ面白いもん作ったね。っていうか、まだまだプロジェクトスタートした段階なので、具体的にこれで何が今開発中だみたいな、プロダクトに関してのアナウンスは一個もないみたいですけどね。ちょっと未来は感じるね。ではでは、失礼します。